Hey guys, welcome to Math 116. This is section 5.2, logarithms. You are in for a treat. Log functions, just like an actual log, can be a little bit slippery and hard for people to wrap their brain around. So hang on and do the best you can. Whenever you're studying exponential functions, you also study log functions. So here, let me get rid of this one. Here's the graph of y equals 10 to the x, that's an exponential function. And here is the graph of y equals log base 10 of x. See? So there, imagine a line, an asymptote of the y equals x line. It's like they are mirror images of each other, mirror butterflies that make up log functions and exponential functions. So the red one's the exponential function that goes up forever, and the log function tapers off. It sort of decays down. It's for things that don't go forever, but that seem to kind of taper off. So here's some of the basics of log functions. Suppose we said, here's the definition. Log base a of x is equal to y. This is telling us the way you write this in exponential form is, I'll make it in red, a to the y is equal to x. Whoa. Okay. Is your brain like, what happened? It's like a big game of musical chairs. That's how I think of log functions. It's the mathematical musical chairs. Suppose I said log base 3 of 81 is equal to 4. If you want to write this in exponential notation, what you can do is you say the 3 goes up, 3 goes there, 81 goes over here, to the other side, right? 3 goes there, 81 goes here, and 4 hops over to the exponent. 3 to the 4th equals 81. Now obviously musical chairs is not the reason this works, but this is just the definition of a log function. Okay, so here's an example problem with this. This is question number 1. It says write in exponential form. 4 equals log base 2 of 16. Okay, so another way I can think of this is the 4 is big and the 2 is little, and they switch places. 2 is big, 4 is little, equals 16 is by itself. So another thing, when you're doing this, especially with numbers, you should be able to check your answer to make sure it makes some sort of sense. And in this case, it does make sense, because 2 times 2 times 2 times 2 is equal to 16. Check! So this is an example of writing it in exponential form. Let's look at question number 5. We can use these properties of logs to solve for x. So this question says solve for x. We have log base 3 of x is equal to 4. This is a fairly simple version of this problem. So to solve for x, you can write it in exponential notation. Exponential notation first, and then it should pretty much solve it for this one. Notation. So in this case, this is the same as saying 3 is little, now 3 is going to get big. 3 to the 4th equals x, and 3 to the 4th, that number is 3 times 3 times 3 times 3 is 81, equals x. And that is your answer. Okay? Here is another one. This is question number 9. Slightly more complicated, but still the same thing. Log base 7 of 3x plus 1 is equal to 2. So the first thing you do is write it in exponential notation. This is saying 7 was little, 7 gets big, 2 comes over here, equals, this is by itself, 3x plus 1. Okay, 7 squared is 49. We subtract 1 from both sides. Ah, it's familiar now, we're on a roll. 48 equals 3x, divide by 3, x is equal to 16. So these, once you can figure out how to write it in exponential notation like this, then you're home free. X equals 16. Huzzah! Yay! So exciting. So there's another rule to keep in mind with these logs, and that is this rule. That log base a of a to the x is just equal to x. So anytime you have the log, the base, and the same thing, this base and this number are the same, then you just have whatever the exponent is. And that makes sense because a to the x, well, that's equal to a to the x. So it's kind of weird notation. But this is how you would potentially use something like this. This is why I'm telling you this. Question number 19. We have e to the 3x plus 5 is equal to 0.55. Okay, a little sidebar. I meant to tell you this earlier. So, plain old log. If you just see log, this means log base 10. So, if, like on your calculator, it says log. When it doesn't say, it always means log base 10. And if you see ln, they call that natural log, log natural, natural log. It's French. I don't know if it's French. And this means log base e. E is a number, remember. But you would never say log base e, you'd say natural log. Okay, back to question 19. E to the 3x plus 5 equals 0.55, and you're supposed to solve for x. Uh-oh, it's okay, we can do it. So one thing you do, because you really want to get rid of this e and just have 3x plus 5 on this side, you would get rid of this e. He's your target. So you take natural log, that's a natural log, log natural, of both sides. You can do that. You can take the natural log of both sides. As long as you're doing it to both sides, you have not changed the equation. So the natural log of e to the 3x plus 5 equals natural log of this, 0.55. Why did I do that? I will show you. This piece here, natural log of 0.55, that equals minus 0.5979. Where did that come from? It's obvious. I'm kidding. You have to do this on your calculator. And there's a button that says ln, natural log of 0.55. It should be minus 0.5978. On this side, we have the natural log of e raised to something. It's this same equation. Natural log is log base e of e. So this looks like this. Log base e of e, 3x plus 5. So that the e's get rid of each other, and we're left with 3x plus 5. They don't really cancel, because it's not a canceling sort of thing, but they effectively go away. We've raised it up and taken the log, so it's the same as doing nothing. So on this side, natural log of e to the 3x plus 5 equals 3x plus 5. Natural log of 0.55 is minus 0.5978. So now we can just subtract 5 from both sides. That gives minus 5.5978 equals 3x. Divide both sides by 3, and you get, finally, x equals minus 0.5978 divided by 3 is minus 1.8659. I know this is a messy looking piece of paper, 1.8659. So this is just the introduction to logs, and I have another video that does a little bit more with some of the properties of logs. So get yourself familiar with logs and do a few of these problems, because there's definitely going to be one like something like this on the test, and you should be able to have a process for dealing with it. Okay.